everyone. Welcome back again to the next lecture on Automata Theory and Computability Module 1. A small recap on the last session. In the last session, we have seen the formal as well as the informal definition of DFA. We have seen a few brief notations that would be used in the construction of DFA, as well as we have also seen what is a decision problem. In today's session, I'll be continuing with the construction of a DFA. So let's begin with the first problem. So here, the question that is given here is, construct a DFA to accept all strings from the language, and the language specified here is epsilon, A, 2 occurrence of A, 3 occurrence of A, and so on. So if we write a regular expression for this, we can write it as A to the power of asterisk, so which means 0 or more occurrence of A. To construct the DFA of this, so first is we have to construct the skeleton of it. So in this case, if you see, the language must accept epsilon. So we will start constructing a DFA to accept epsilon, which is, so this is the notation that is used, that was used to accept epsilon. And onwards, if you see, the next string that the machine should accept is A. And then 2 occurrence of A, 3 occurrence of A, and so on. So what we can do here is, instead of going to the next state, so we can have a self loop indicating A. So this would satisfy all the condition of from accepting epsilon, a single A, 2 occurrence of A, 3 occurrence of A, and so on. So just to justify this, now for example, if I take an string which is 3 occurrence of A's, and then I'll try to do the state transition for this. So I'll start with the state transition. So initially we are there in the Q0 state, which is the current state, on accepting an input string A. So you can see that we still remain in the same state, Q0. Now coming to the next one, since Q0 is the current state, so I'll be starting with the current state. On accepting a symbol A, you can see that we still remain in the same state, Q0. And the next one, epsilon, I'm sorry. So next one is Q0, A, and the next state is A, because we are looping back again to the same state. So since this is the final state, so we can state that the string is accepted by the DFA. So this is one of the basic problem. Now coming to the next question. So in the next case, if you see, the question reads that, construct a DFA to accept all strings from the language that consist of 1 occurrence of A, 2 occurrence of A, and 3 occurrence of A. So the previous problem, it also included epsilon, but in this case, it starts from 1 occurrence of A. So the regular expression of this is A plus, and to construct the DFA, we'll start with the skeleton. So first draw the skeleton for the minimum string. So I'll start with the state Q0. On accepting an input A, it reaches the state Q1. Okay, so which is the final state. Now since this is a DFA, there are few other points that we have to remember. Remember that every state should make 1 transition per input. Now if you see the language consists of 2 alphabets. The language consists of a single alphabet, which is A. Now start with Q0. Q0 is already made an transition over A. So an input transition is made on seeing an input symbol A. Now coming to Q1, Q1 has not made any transitions for the input symbol. So we need a transition for the input symbol here. So in this case again, so when do we reach Q1? So when I'm there in the state Q0 initially, so there is no acceptance. When do I reach the state Q1? This is reached after accepting A, we reach the state Q now. Now being in Q1 as the current state, now we have to make a transition for A. Now, so this is A. Now what happens on seeing another A? So this string should be accepted because this is a valid string in the language. Similarly, if I have 3 A's, this should also be accepted. If I have another A here, this is also should be accepted. So one better way is we can have a self loop here and write A here. Now we can see for an acceptance, we will take the same string and check whether this string is accepted or rejected. Now starting with to write the transitions, I'll start as, so initially we are there in the current state Q0. On seeing the very first input, which is A, so it makes a transition to the next state, which is Q1. Okay. Now Q1 becomes the current state. Okay. So being in Q1, on seeing the next input symbol, on accepting the next input symbol A, so you can see that this is a loop, so it still retains in the state Q1. Now the third one, so the next state is Q1, so this becomes the current state. On seeing the third input, so you can see that we still remain in the same state Q1. And being in the state Q1, which is the current state, on reading the next input symbol, which is A, you can see that we still retain in the same state Q1. Since Q1 is the final state here, since this is the final state, we can state that the string is accepted by the DFA that is constructed here. So this is the second problem here. Now coming to the third problem. The third problem is to construct a DFA to accept all strings over A from the language. The language states that it should accept all the strings with even length. So which means that when I am writing the language can contain epsilon, it can contain 2 occurrence of A, 4 occurrence of A, 6 occurrence of A, and so on. All the even numbers here. Okay. So the regular expression that I can write for this is AA asterisk. So this is the regular expression, which means that, so the asterisk symbol here, this tells 0 or more occurrence of the pattern that is present here. Now for example, if I take this as, so in this case, so initially if I take it as 0 occurrence, so this would be epsilon. 1 occurrence of this pattern, you will get AA. 2 occurrence of this pattern, so for the first occurrence is this, for the second occurrence of this, and then 3 occurrence of the pattern, so you get 6 A's, and so on. So this is a valid expression that we have here. So to draw the DFA for this, now the first thing is you can see that the machine should accept epsilon. So start with the notation that is used to accept an empty string, so which is Q0. So when I write this, the DFA will be accepting epsilon. Now the next thing is, it tells that it has to accept AA. So what I'll do is, on seeing an A, so on accepting an A, it makes a transition to the next state, which is Q1. Okay. Now Q0 is made a transition on seeing an input symbol A. Now this is done. Now coming to the next state, so in case of DFA, always remember that every state must have one transition per input. So in this case, we have only one input symbol, which is A. So Q0 is already made a transition on seeing an A, it is moved to Q1. Now Q1 should make a transition on seeing an input symbol, which is A. Now if I have another input symbol, now what I can do is, I can write this in this way. So this is on accepting A. Now always there is a question, why cannot I have another state here? Now for example, let me assume that instead of this, so let me assume that I make one more transition of A and then go to the final state, which is Q2. Now if you analyze this DFA, it accepts epsilon, and you can see that it will accept 2A. Okay. Now let's see what happens to when there is 3 A's. Now for example, if I make a transition to Q0 on seeing a A. Now if you can see that if I have 3 A's, which is actually an invalid string, that would be accepted by the DFA. We start from Q0. So on reading the first input symbol A, you reach Q1. On reading the next input symbol A, you reach Q2. On reading the third input symbol A, you reach Q0, which is again a final state, which means that this design here, or this automata design that we have constructed here, it is also valid for the odd occurrence of A's. So it's always better to go on to the next condition. So instead of having this, so what we can do is, we will not be taking another new state. Rather, what we can do is, so Q1 should make a transition for A. So what I'll do is, I'll just have a transition from Q0 to A, from Q1 to A itself. So this is on accepting A. Now let's see whether this works for the condition where I have 4 A's. Now let me assume I have 4 A's, and then let's see the transition. So I'm going to start with delta from the state Q0, because this is my current state. On accepting the first input symbol, which is A, so it makes a transition to the next state, which is Q1. Okay, now Q1 is the current state. Being in the current state and accepting one more input symbol, that is the second input symbol A, you can see that it makes a transition to Q0. Then again, I'll start with Q0, which is my current state. I'm here in Q0 here. And then on accepting the third input, which is A, you can see that it makes a transition to Q1. So I'm back again here to Q1. So the next state Q1 becomes the current state. On accepting the fourth input symbol, which is A, we go back to the state Q0. Now see, at the end of this input symbol, after accepting all the input symbol, you can see that it is in the state Q0, which is actually the final state, and so your string is accepted. So similarly, let me take one more example where I have three occurrence of A, and check whether this is accepted by the design that we have done. Now starting with Q0. So I'll start with the start state. So delta Q0. On seeing the very first symbol A, so you can see that it makes a transition to Q1. So I'm here in Q1. Now delta Q1 becomes the current state. I'm here at this location Q1, and on reading the next input symbol, which is A again, on reading the next input symbol A, you can see that you get back to the state Q0. So Q0. Now let me come to the next. So Q0 becomes the current state. On seeing the third input symbol, which is A, you can see that we get back to the state. It makes a transition to the state Q1. Now we have already reached the end of the input string. At the end of the input string, we can see that we are at the state Q1, which means that the string is not accepted here. So this is invalid. It rejects the string. Okay. So, and that's because at the end, after accepting all the inputs that is present here, it has not reached the final state. It is into the non-final state. Okay. So this is the explanation for the third problem. And let's come to the next one. Okay. So in the next problem that I've taken is to construct a DFA to accept all strings over A from the language where the strings must contain odd length. So in this case, the language that is given here is, we have A followed by 3 occurrence of A, 5 occurrence of A, and so on. So the regular expression for this is, so you can see that I can have A followed by 0 or more occurrence of this pattern AA. So for example, if I have 0 occurrence of this, so I'll be having only A. If I have 1 occurrence of this pattern, so this A is going to retain as it is. So I'll have 3 A's. If I have 2 occurrence of this pattern, you can see that I'll have 4 A's. So all these things will give rise to the odd length strings. So now let's see so more in detail about this you'll be seeing in the second module. So let me construct the DFA here. So to begin with, so first construct the DFA for the minimum string, which is A. So at the end of this DFA, we can see that the string A is, so this construction here, this accepts 1A. Now we can see that, now start with Q0. Q0 is already made a transition on seeing A. And here we have only one input symbol. So Q0 is already made a transition with A. Now come to Q1. Q1 is yet to make a transition on seeing the next A. So what we'll do is, now we can see that it clearly tells that it should accept 3 A's. Now what happens if I put a self loop of A here? Okay, that's one possibility that I can do here. But then you can see that if I have 2 A's, if I have 4 A's, which is the even length, all these things would be accepted with this DFA. So how will it accept 2 A's? So I'm here in Q0. On seeing, on accepting an input A, it goes to the state Q1. On accepting the next input A, it retains in the final state, which is Q1, which means that the even length string is accepted here. So this should be the invalid design. So what else is possible here? So now let me go to the next one. Always remember that we need not always try to build upon the skeleton that we have drawn for the initial string. So we need not bring across a new state here. So just avoid this, so that is not required here. Just stick on to the skeleton that you have obtained with the minimum string. So what we'll do is, now when we are in Q1, we should ensure that it is accepting even length of string. So only one possibility that I have here is, I can have an transition back to Q0. Now let's see whether this DFA is accepting 3 A's. So I'll start with, so we'll check with the transitions. So I'm starting with Q0, which is the current state. On seeing the first A, so you can see that it goes to the state Q1, right? Q1. Now again, so the Q1 becomes my next, my current state. Being here in Q1, on reading the next input symbol or on accepting the next input symbol, we make a transition to Q0. Now being in Q0, you can see that on accepting the third input A, it makes a transition to Q1. And you can see at the end of the input string, after accepting all these 3 A's, we are in the final state, which is Q1. So this is valid. Now what happens if suppose I have only 2 A's? If I have only 2 A's, then, so let me check if this string is accepted. So I'll start with delta Q0. So I'll start with the initial state. On accepting an input string A, it makes a transition to Q1. And then, now Q1 becomes the current state. On accepting the second input symbol, which is A, you can see that it makes a transition to the state Q0. At this point, I don't have any other input string, so it gets stopped here. Now you can see that Q0 is a non-final state, which means that the even length of the string is not accepted. So this is the fourth problem for today's session. Now let me come to the next problem. In the next problem, if you see, the question reads that we are supposed to construct a DFA to accept strings of A's and B's having exactly one A. So all the strings that is present in the language must have only one occurrence of A. So we have A here, and then we have A followed by a B, and then we have B followed by a A, and then we have two B's followed by A, which is again you can see in this string, in this particular string we have only one A, exactly one A that occurs. And then you can see there is, and one more thing, there is no constraint on B. So we can have any number of B's here. Now if I see this, again you can see exactly this string has got one A followed by two B's. Again I have 3 B's followed by A. I can also have BA, BB, and so on. Any such strings that can be considered here. Now, if I have to construct a DFA here, now start constructing with the minimum string. So always remember, the step 1 would be to identify the minimum string. So here the minimum string is A. So minimum string is equal to A, and the alphabets that I'm going to work on here is A and B. All the previous problems we had seen that there was only one symbol, only one alphabet that we were using. So in this case I have 2 alphabets, A and B. Now first draw the skeleton for the minimum string. So I start with the state Q0 on accepting A. So Q0 is the current state. On accepting A, it makes a transition to Q1. Okay. So now this condition is done. Now check whether this is in a DFA. So you can see that this is not a DFA because, as already said, that every state must have one transition per input symbol. So if I take Q0, Q0 should have made one transition for A and one transition for B. Similarly, Q1 should make one transition on A and one transition on accepting the input symbol B. Now let me start with the start state. Now I'm here in Q0. Now what happens if I'm seeing a B here? I'm accepting a B here. So before that, let me write down this. So when I'm there in this state Q0, there is no acceptance. So initially you don't accept anything, only then you are there in the state Q0. So when I reach Q1, this is after accepting A, you reach Q1. Okay. Now I'm in Q0, right? You are in Q0. And what happens if you see a B? So if you see a B, whether this should be accepted or not accepted. Since there is no constraints on B, or so one more thing you can see that. So if suppose I have a B followed by a, this should be accepted. Similarly, if I have 2 B's followed by A, this also can be accepted. 3 B's followed by A can be accepted. So one or more occurrence of B followed by A is actually a valid string here. So the possibility here is I can have a loop here. So you can see that by putting this loop, so I can have one occurrence of B and then one occurrence of A. So B, A is accepted. Now if I have 2 B's and A, you can see that. So Q0 on seeing the first input symbol B, it reaches Q0. Q0 on seeing the second input symbol B, it stays in Q0. And on seeing an A, it reaches Q1. So this condition is satisfied here. Now let me come to Q1. When do I reach Q1? Basically on seeing an A, you are reaching Q1. Now Q1 should make 2 transitions because it is not made a transition on seeing an A as well as on seeing an B. Now let me think. If suppose I've reached Q1. So after seeing a I've reached Q1. What happens if I see another A? So in this case you can see that there are 2 A's, but the question clearly tells that it should have exactly 1 A. So in this case, if suppose it has to, if there is a situation where it accepts more than 1 A, then ensure that this is put into the trap state or the error state. So what I can do is, on making a transition on A or being in the state Q1, if I see one more A, what I do is I go to a state Q5 and this state is actually called as a trap state. So trap state, so no other transitions can happen here. So again, being in the state Q1, if I have to see B, so Q1 is already made a transition on A. Now what happens if I see a B? So let me write it here. So when I reach Q1, only after seeing an A, I can reach Q1, or a BA, I can reach Q1. So let me take the minimum condition. On seeing a A, I reach Q1. Now being in Q1, what happens if I see a B? So AB should be accepted because that is valid. Similarly, A followed by 2B should be accepted. This is also valid. A followed by 3B's should also be accepted. This is also valid. So what I can do is, so wherever you have one or more occurrence of B's, so it's always a better option to go for a loop. So I can go for a loop here. Okay. Now you can see the condition here. Now this would satisfy almost all the conditions here. And one more thing is, when you are there in the trap state should also make a transition for both the input symbols. So only then this is an DFA. So when I am there in the trap state, on seeing an A or a B, this is going to loop to itself and retain in the error state. Now let's see the acceptance of this particular problem. So let me take a string, and the string is BA followed by BB. So we'll see if this string is accepted. Now I'll start with delta. Start the transition with the current state, which is Q0. On seeing a B, so the first input symbol that it has to accept is B. So on seeing a B, Q0 on seeing a B, you can see that it is there in the same state Q0 because I've written a loop here. So this becomes Q0. So this is the next state. Now this becomes the current state. So I'm still in Q0. And what happens when I see the next input symbol, which is A? So when I read an input symbol A, so what would happen? On seeing an A, it makes a transition to Q1. So I'm there in Q1. Now again, so you can see that I'm there in Q1. And what happens when I see the third input symbol, which is B? On seeing a B, you can see that we are just looping back to Q1. So I'm just staying back in the same state, Q1. Now the Q1 becomes the current state. What happens when I see the fourth input symbol, which is B again? So you can see that it still retains in Q1. Okay. Do I have any other input? Since I don't have any other input, so this is the end of my string. So you can see at the end of the string, after accepting all the four strings, you can see that it is present in the final state. And since it is in the final state, I can tell that this string is valid and it is accepted by the DFA that is constructed. Now let me take one more condition. What happens if I see A instead of B at the end? So instead of B, what happens if I have a A? So what happens if I have a A? So in this case, you can see that, so the last transition, so up to this it's going to remain the same. So you can see that Q1 on seeing a B is going to retain in the same state Q1. Now I am in the current state Q1. If my fourth symbol was A, so then what you can see is it gets into the error state or the trap state, and you can see that it makes a transition to the trap state. So any A's and B's after that particular symbol, it will still retain, it will loop back into the error state. So it will get held, it will get halted here. It goes on looping in this condition. So in this case, you can see that it reaches the error state or the trap state. So this is not the final state. So this becomes the error state. Okay, and the string is not accepted because you have more than one A's.